Welcome to 20th lecture in the subject Industrial Engineering and Operations Research. Now, today we are going to discuss the problem of assignment. Assignment does not mean weekly assignment which I give to you, rather here assignment means assigning work to somebody. Okay. So, assignment problems are of that nature that suppose you have got 5 jobs and there are 5 workers. Now, in what way you should assign so that your performance is maximized. So, this type of problem is called assignment problem. There may be 5 teachers and 5 students, 5 jobs, 5 workers, many such type of problems can be. There is some mathematical relation that if you assign job X to person Y, then how much is the gain, like that. And this topic is in fact included in the books on operations research as well as in the books of industrial engineering. So, basically because we are going to do some type of mathematics, so therefore it is a part of operations research. We are a type of optimizing the things. So, here if I go to assignment method, so in assignment method it involves task or jobs to resources, basically assigning task or jobs to resources. It is a way of allocating organizational resources in which each resource is assigned to a particular task. So, resource could be monetary or technological. So, it could be money wise, like you have got 5 factories and you have to assign say certain amounts to them, that or it can be technology wise, you have 5 jobs, 5 machines, in what way it has to be done. So, assignment method is used to determine what resources are assigned to which department, machine or center of operation in the production process. Objective is to minimize total costs or time required to perform the task at hand. It can be maximize profit also. Okay. Just maximization is, you can say, is a mirror of minimization. So, it should enhance production efficiency. So, assignment method has various application in maximizing resources. We can give some examples. Allocating the proper number of employees to a machine or task. How we should allocate? Allocating a machine or a manufacturing plant, number of jobs that a given machine or factory can produce, that also we can allocate. Assigning new computers, laptops, tablets and other expensive high-tech devices to the areas that need them the most. Lower priority departments may get the older models, like that. You can make the system that here there is a too much requirement of computer, so give a better quality computer here. Other side you can have maybe low speed computers also. So, assigning a number of salesperson to a given territory or territories, you have got suppose 5 territories and you have got 5 salespersons. So, in what way you should assign them so that you can get the maximum benefit, that is also there. So, we give that example that we will naturally will discuss a simple model, and complicated models can also be done with the help of computer software. Nowadays there are ready-made software also, but our purpose is to teach you the basics. So, therefore, we take a simple example. Suppose we have 3 different 3D printers, that is printer 1, 2 and 3, okay, and they are available at a factory. Now, 3 products are to be fabricated. You know that with 3D printer or additive manufacturing machine, you can make the products. So, let us say that we have to make 3 products A, B and C, and how should they be assigned, that on which printer I should give A, on which I should give B, on which I should give C. So, let us say that we know the cost of producing that product in different printers. If product A is produced in printer 1, it takes it costs rupees 120, in printer 2 it costs 140, in printer 3 it costs rupees 60. Similarly, product B costs rupees 80, rupees 100 in printer 2 and rupees 110 in printer 3, and product C costs rupees 90 in printer 1, rupees 120 in printer 2 and rupees 70 in printer 3. If you just think that okay, let us say that I should assign the lowest cost item here, like product A costs minimum on printer 3, so let us give A to 3 and then you can give B to 1, but then you cannot give that C to 3 because that is already engaged. Although the lowest cost rupees 70 is there, but you cannot give that, so you don't have any option except that giving C to 2. So we don't know that whether it is optimal or not. Maybe here you can do very fast by hit and trial way because only 3 product and 3 printers are there. But suppose I would have given you 10 products and 10 printer, then it would have become even difficult. So the point is that in printer 3 is capable of making A as well as C at a very cheap rate. But you can give only A or you can give only C here. So that's why you have to make some method. So we have to make optimal assignment that minimizes the overall cost. You have to minimize overall cost. So assignment method involves adding and subtracting appropriate numbers in the table to find the lowest assignment or optimal cost. It is the value of what one lose when choosing between 2 or more options. So this is a method. This type of method is called Hungarian method. This method has been devised and it is popular by the name of Hungarian method. And here the steps will be like that you will do some relative type of analysis, that suppose you product A you assign to printer 1, so you are paying 120, but basically effectively you are losing rupees 60 because otherwise also you have to assign it to printer 3. So therefore 120 minus 60, that means 60 is the penalty you are paying. So we find out those penalties and we try to minimize that penalties. So subtract the smallest number in each row from every number in that row. Like suppose for product A, I subtract 60 from 120 and 60 also from 140. So it will become 60. It will become, suppose I do that, so it will become 60. It will become 80. It will become 0. Okay, this will become 0. Similarly, I will do that for this also. 80. It will become 0. This will become 20. 20 more than the minimum, this is 30, and here what I will do that this is 70, so 70 becomes 0, this is 20, this is 50, right? And then we will do column wise also, that suppose column wise 60, 0, 20, so here anyway minimum value is 0, no problem. Here also this is 0, but here 20 is there, so 20 will subtract from 80 also, 50 also and 20 also. So we will do this thing column wise also. Anyway, let us first read this. Subtract the smallest number in each row from every number in that row. I have already done that. Then from the resulting matrix, subtract the smallest number in each column from every number in that column. So that means I have to do subtract this also. This is 20, but I will make it 0. And then if I make it 0, then this becomes 30 because I have to subtract this one. So this is 30 and this becomes 60. Okay. So this will become 60 here. So like that we have to do. This step has the effect of reducing the numbers in the table until a series of zeros. So we got many zeros here. Okay. Now what we will be doing here? Now after that, draw the minimum number of vertical and horizontal straight lines to cover all zeros in the table. If the number of line equal either the number of rows or the number of columns in the table, then optimal assignment can be made. If the number of lines is less than the number of rows or columns, then proceed to step 3. That means what happens, we will do minimum number of lines to cover zeros. Say suppose I do here, so you see that it is 2 zeros are covered like that. Here 2 zeros are covered like that. Okay. So we have done covered that. So minimum we have got basically 2 only. Now 2 lines have covered all the zeros, but we need basically 3 lines because we have to assign 3 things. So therefore we have to do next step also. Okay, we will see that what can be done. So step 3 is that once you have your lines are less, like we need to cover the number of zeros, but we could draw only 2 lines. So subtract the smallest number not covered by a line from every other uncovered number and add the same number to any numbers lying at the intersection of any 2 lines. So return to step 2 and continue until an optimal assignment is possible. That means I have covered by these 2 lines, but you see that 20 is still remaining. So we have to uncover this 20. So 20 will be subtracted from everywhere except that intersection line. There you will not do anything. But here, since these are 2 lines covered here, so we will add here 20. Okay. So we will put here 20. That means this was actually 30, but it will become 50 here. Okay. So this process also we do. So here an optimal assignment will always be at 0 locations in the table. Select a row or column that contains only 1 0 square. Assignment can be made to that box and then draw lines through its row and column. That means this is finished. From the uncovered rows and columns, choose another row or column in which there is only 1 0. Now assignment is made and the procedure is continued. New assignment is made and the procedure is continued until assigned each person or machine is assigned a task. So until each person or machine is assigned this one. That is until assigned, you can put a comma here. Okay, each person or this one. Okay. So let us give that example only. I have already explained you, but I am elaborating it again. Different 3D printers. So suppose this is given. Now what is the first step? Subtract the smallest number from each row. So you see that I have subtracted 60 from first row. So I got this much. I subtracted 80 because that is the lowest number in that row from this one. So you got 0, 20, 30. Then what I did? Then I got 70 from each this one. So this is 20, 50 and this is 0. So subtract the smallest number from each column now. So first here I need not do anything because this is 0, so 60. But here 20 is the smallest number. So 80 minus 20 is 60. This is 0, this is 30 and this is 0, 30, this one. Now what is the third step? Again, draw minimum number of vertical and horizontal lines needed to cover all zeros as shown below. What we have done? One line we did this, which cover 2 zeros at one go, other is horizontal. So 2 have been done, but we are still remaining that some, we don't have 3 lines. I need 3 lines because there are 3 product and 3 printer. And this is 20, 30. So 20 is the lowest. So subtract 20 from 60, you get 40. So again printer 2, 60, uncovered one. Covered one don't touch, but at the intersection you have 30. So you add 30 plus 20 is equal to 50. And this is 0. And then you got 10 and you got 0. Okay. So this is 10, 0. So now add it to numbers at the, so you have got that type of thing. Now what you do that? Select the row or column that contains only 1 0. So now assignment is done because you see that now we can draw 3 lines. This is 1, this is 2 and this 0 is uncovered. So you have to make something, either you do this way or you do that way, means either you cross the row or you cross column, but effectively you will have 3 lines. So how to do that? Now select the row or column that contains only 0. So suppose this one is the basically final matrix was what? This was the final this thing that I have reproduced here. Now see, row 1 is containing only 1 0. So make it in square. Okay. So that means A can be assigned to printer 3 nicely. And then what you have to do, this is done, and from the uncovered rows, so therefore since it is already assigned, so A row will go, printer 3 will go. You can't do anything to printer 3, you can't do anything to product A. So what will be happening, that here 0 0 0 10 this type of thing is there. Now what you do, that better you have to assign something here from the uncovered rows and column, choose another row or column to where there is only 1 0. So what is that situation, that where there is only 1 0, maybe here 0 10, here it is only 1 0 because this is already classed, so 0, so you put that this, and then after that this will go, so you don't have any choice except that you have to take this one 0. Okay. So that means assignment is done, and therefore you have already optimal assignment now you have made, that printer A goes to printer 3, B goes to printer 2, and C goes to printer 1. So you can you have data, A goes to printer 3, that means 60 rupees will be spent here, and B goes to printer 2, that means 100 here, from that was the original table, and then it is going printer C is going to this one, product C is going to printer 1. So therefore 90, so 60 plus 100 plus 90, that becomes rupees 250. Okay. So product B in printer 2 and product C in printer 1. So this becomes basically 250. Okay. So that has come, and this type of thing has been done. So now we give that one more example to make you confident, and suppose 3 PhD students X, Y and Z have to be assigned to 3 supervisors A, B and C. Estimated number of papers, okay, each pair can produce in 5 years are given in the form of matrix, that you know, if student X works with supervisor A, in 5 years he can produce 15 paper. It is estimated that if he works with B, then frequency will not match that much and he can produce 10 paper, and here at C he can produce, with C he can produce 9 paper. That means student X and supervisor C can produce 9 papers. Similarly, if Y goes to A, then 9 papers can be produced, Y goes to B, that 15, and if Y makes C as a supervisor, then 10 can be produced. Similarly, ZA combination gives 10, ZB 12 and ZC gives 8. Okay. So now naturally our interest is that how should I assign students to supervisors such that the department publishes the maximum number of papers. So department's interest is to publish maximum number of papers. So it is the reverse problem. Now we have to maximize these numbers, not minimize. Earlier we have to do that. So it is a classic assignment problem which can be solved using the Hungarian algorithm or other optimization technique, of course integer programming, which I have not taught yet. The goal is to maximize the number of papers published by assigning students to supervisor in the best possible way. Now apply the Hungarian algorithm maximization case. So convert the problem into minimization problem by subtracting each element from the maximum element in the matrix. So we can do that, or otherwise we can make everything negative also. That means we can say minus 15, minus 10, because everything. Otherwise here what we do, that here suppose we have to subtracting each element from the maximum element. That means maximum element is here suppose 15. So subtract 15 from everywhere. So that means suppose he publishes 9 paper, so it will be only a type of penalty. So that means solve the transform problem using the Hungarian algorithm which finds the optimal assignment. Otherwise the Hungarian algorithm solves minimization problem. So we convert the given matrix into a cast matrix by negating all values. So we can do like that also. we can have transformed matrix as minus 15, minus 10, minus 9, minus 9, minus 15, minus 10, minus 10, minus 12, minus 8. That type of thing we can do, and you should have said. Otherwise, other way was that I could have said that minimization problem can be done this also, that suppose 15 papers, so this is 0, but this I would put 5. So that means 5 penalty type of thing. Then my task will be minimization of the penalty. And this I would have said 15 minus 9 is 1. Similarly, 15 minus 9 is 1. This is 0. No penalty, that means maximum. And this is a 5. And then 15 minus 10, 5. This is 3. This is 7. Now these penalties you have to minimize that actually. So your tendency will be assign x to a like that, because x you will get 15 papers there, is it not? But anyway, so both the things can be done, but I am negating these minus 15, and then follow the same procedure. For each row, subtract the smallest value in the row from all elements in the row. So suppose minus 15 is the smallest, then you subtract it here, 0, 5, 6. Basically you got same type of penalty here. You see 0, 5, 6 and here 6, 0, 5 and 2, 4, 0, because minus 12 is the highest, lowest value, that is smallest value in the row from all elements in the row. So you are subtracting that and you get 2, 4, 0 like that. So it is basically you have done penalty type of thing only, that this is 12, but here it is 10, so it will be penalty. Okay. So now for each column, subtract the smallest value in the column from all elements in this one. So here what happens, that here you subtract that smallest value, that is 2, and then you have to say that this is 0, 5, 6, so it is basically 0 only, and then this is 6, 0, 5. Okay. So you will be doing that this one, and then 0, 4. So suppose you can do that. So this is 0, 4. So for each column, so you have to do this for each column. Okay. Smallest value from all elements in the column. Okay. So this becomes like that. This is 6, 5, 0. This is 5, 0. This one, and this is 0, 6, 2. Okay. Already means I have written this step, but actually you don't have to do anything, because already it is 0. In each column there is 0. So you don't have to do that. Now already if I see that 3 lines which cover that, so one I can do that at one go, this one, another I have to do this, and the third maybe we have to do this. So we have 3 lines, but anyway now use the Hungarian algorithms 0 covering method. We determine the optimal assignment. How? Suppose we go to this one, say column 2, there is only 1 0. So better to assign it first. Okay. Now once we have assigned this, let me make it first neat and clean, then you will understand that suppose we got this type of matrix. So in this second column only 1 is there. So square it, that means this number 2 student can go to number 2 supervisor, no problem. And then what happens, that if it goes, so this is already assigned, so it is not in the row. Of now you have only left this one. In first row you have got only 1 0. So assign it actually. Now you have assigned, so this goes and this goes. Then you don't have any option except to assign 3 here. Okay. So you get here 3, and so student Z to supervisor C. So assignment is made, that student X goes to supervisor A, student Y goes to supervisor B, student Z goes to supervisor C, and the total maximum papers published will be 38. Okay. So that type of thing can be done. Okay. So this is the problem got solved. Now let me just give that one more example in which there are actually 4 assignments to be done. That means 4 rows and 4 columns. So 1 degree higher. That's why I am giving this example. A manufacturing company has 4 jobs, J1, J2, J3, J4, that needs to be assigned to 4 machines, M1, M2, M3, M4. Now each job must be assigned to exactly one machine and each machine can handle only one job. The time taken in hours for each job on each machine is given in the following cost matrix. So time is given, J1 if it done on M1 it takes 12 hours, in M2 it takes 7 hours, like that. Now M3 okay, cannot do job this one, okay, cannot do job this one. So I have left a blank, okay, it cannot do that job. So maybe you apply that very high number here, that type of things you can do that. We don't have to assign M3 to J2, okay. So put a very high number, maybe I can put 100 or something. And now you can use the Hungarian method to determine the optimal assignment of jobs to machine such that the total time is minimized, okay. So assuming a large value in place of missing time so that it will become unsuitable for assignment, I have added 100 here. And then follow the same method that step 1, that means in each row lowest value is suppose here 7, so subtract 7 in 12, so 12 is subtracted from 7, so 5, 0, 2, 4, and here smallest value is 5, so 8 minus 5 is 3, this is 0, this is 95, 2, and like that I did in for row 3 also. Smallest value is actually 8, so 6, so 6 minus 6 is 0, then 8 minus 6 is 2, 10 minus 6 is 4, and 9 minus 6 is 3, okay. Smallest value is here 6. Same thing is done in the 4th row also, that smallest value is 6, so 6, so you subtract everything from 6, 7 minus 6 is 1, like that you got. And then you do same thing column wise. So in M1 column already there is 1 0, so no change will be there. In column M2 already 0 is there, no change will be there. In column M3 the lowest value is 2, so everything will be subtracted from 2. So this becomes 0, this becomes 93, this one. And here in column M4 lowest value is 2, so then everything will be subtracted from 2, so it becomes 2, 2, and this becomes 0, and this becomes basically 0, so it becomes basically 0. This will also come out to be 0, okay. So this is what that becomes like that, okay. This is 5 minus 7, 2, so this becomes like this. Now what happens that now go to this one, so we can assign that now this machine. So here it was I think 0 here, okay. So therefore what happens that now M1, M2, M3, so we have to see that how we can assign that, okay, whether I have to go for more steps or not. Suppose we cover the 0, this is covered already, then 2 line is this, then 3 line I can say this, and this is 4. So 4 lines minimum are needed. So we don't have to do anything. I think we can stop the procedure here. Only thing that now we have to assign. So now assigning means that I have to assign, let us say in M3 column there was only one thing, so therefore I assign it here. I can square it here. I have indicated it by X, but I am making it here by red pen. So this is gone, okay, assigned. And now what happens that remaining that thing is maybe you have got here the only 1 0 is there, so you assign it like this, and you can say that this row goes, this column goes, and then you have got basically there is a 0 here. So here in this column there is this 0, so you can assign that maybe 1 0 here, okay. So you can just go like this, and then you can assign that 1 0 here like that. So you can calculate that minimum total time is equal to 28 hours, okay. So a company, so another example, a company needs to assign 3 workers to 3 different jobs. Cost in each rupees of assigning each worker to each job is given in the matrix that is given, and this is matrix on here itself, not on the next page, it is here itself. So this is given. So to determine the optimal assignment using the Hungarian method, follow these steps, construct the cost matrix. So, given the caste matrix is this. Then row reduction, row minimum is 7. So, in the first row it will be like that, in the second row minimum is 500. So, everything will be subtracted from 500, row C minimum is this. So, this is the reduced matrix. Then you do column reduction, no change in column Y and Z because already there are 0, only here X column will change. So, minimum value is 100. So, 100 you subtract from 100 everything. So, 500 minus 100, 400, 200 and this one. So, you just see that if you can cover this one and this one. So, it is already you have got 3 zeros and I think that here assignment. So, therefore, mark 1 0 in each row. So, now it is obviously that Y has to go to A and then X has to go to C because in this column only 1 0 is there, and then remaining you do not have any choice, Z will go to B. So, assign C to X 0, assign A to Y 0 and this assign B to this one. So, this is the assignment C X this one and these are the corresponding castes. So, total minimum caste is 1900 and optimal assignment has come. So, you will get minimum assignment caste as 1900 rupees. Okay. Here one point is there that if you have got let us say 3 jobs and 4 machines, then what to do that actually? Then you have to put a dummy type of that thing, okay, dummy column, and you can actually put a caste associated caste, you can put 0. So, suppose you have, so it becomes a, suppose there are 4 machines M1, M2, M3 and M4, but you had only 2 jobs. So, J1, J2, J3 and this becomes dummy job. Okay. So, this is JD. Okay. So, that means suppose JD is assigned to some machine, that will not have any significance. Okay. That means you have to basically ultimately you have to assign as per that. So, sometimes the jobs may be less, machines may be more, and sometimes jobs may be more, but machines may be less. So, then you can make a dummy machine, and naturally that if you assign some job to dummy machine, so that means that job will not be assigned basically. So, that type of problems can also be done. Okay. So, we conclude this topic on assignment now. Thank you for your kind attention.